In this video, I'm going to be walking through and modeling some of the concepts and strategies that we use for equivalent fractions. So first I want to get a common understanding of what equivalent fractions are. We noticed today that equivalent kind of sounds a lot like equal, and that's because that's what it is. It's fractions that are equal to each other, and that's because they're either the same size or they're at the same spot on the number line. So sometimes fractions might look a little bit different, partitioned in a different way, but they can still be equivalent to other fractions. So we're going to look at some of the strategies that we use in third grade. I will make a quick note that in third grade we do not use least common denominator, but in fourth grade they will. So in fourth grade they will be multiplying numerators and denominators to find equivalent fractions. Third grade we're doing the step before that, the why. How do you know fractions are equivalent? And that's because they're the same size or the same spot on the number line, even though they might look a little bit different. So we're going to get started here with these two examples. I have this circle partitioned into halves and this circle partitioned into sixths. And I notice that 1/2 is shaded and 3/6 are shaded. And at first you might think, nope, those are not equivalent. But if you look at this fraction in a different way, if you took away these partition lines, you would see 1/2 at the top is shaded and 1/2 at the bottom is not. Or halves are two equal parts. Well, I see 3 shaded, 3 not shaded. 3 and 3 are equal, 2 equal parts. So this shows me that 1/2 and 3/6 are equivalent, even though right away they might not look it. So I want to give you some different examples of what we might think about as we're trying to determine other options for equivalent fractions. So here I have 1/2, and I want to find other fractions that are equivalent to 1/2. And so I'm going to go back to what we've been working on all year when we've been doing fractions, is that halves work really well with fourths, and they work really well with eighths. So I'm going to think, how many fourths are equal to 1/2? So I'm going to draw my hole, and I'm going to shade in 1/2. And then right underneath it, I'm going to draw another hole, and I'm going to partition it into fourths. And I'm going to shade in the same amount. Okay, so I have to really be careful there. So I just found out that 2/4 is equal to 1/2. Okay, but I also know eighths work well. So I'm going to try eighths also. So I'm going to draw my hole. I'm going to partition it into fourths and then eighths. And then I'm going to shade in the same size. Oh, I just found out that 4/8 is equivalent to 1/2. Now you'll notice here that I did my best to make the whole the same sizes, because we've had conversations about how you can't compare half of a small pizza to half of a large pizza. Well, that's the same here. You can't compare.
Final call for Route 11. Final call for Route 11.
You can't compare halves in a small hole to fourths in a larger one. It's just not going to work that way. So you need to make sure that the holes are the same. And then I like to use my half here to partition this half to make the fourths. And then I like to use these fourths to then make my eighths. So everything kind of lines up well so that I know if I'm, finding equivalent fractions or not. I just like to use that. You do it that way, be organized about it. So this example here, I found that 1/2, 2/4, and 4/8 are all equivalent to each other. So 4/8 and 1/2, 2/4 and 4/8, 2/4 and 1/2, all are equivalent. All right, let's do another example here. 4/6. So I'm going to make thirds to make my 4/6. I'm going to shade in 4 of the sixths. All right. Now, when I think about 6, I know that thirds work well. So I'm going to draw a hole here, and I'm going to partition that into thirds. So I'm going to try to look and see where my thirds were there. There's my thirds. And now I'm going to shade in the same size the best I can. So I just realized that 4/6
All buses and vans have now been called
is equivalent to 2/3. So 4/6, 2/3 are equivalent. And again, I know sixths work well with thirds, just like I knew halves worked well with fourths, worked well with eighths. And so that helped me find equivalents. All right, we're going to do one more example here, and I'm going to do 3/4. So I'm going to use my halves to make fourths, and I'm going to shade in 3/4. All right, now I know fourths work well with halves, so I'm going to make halves here. And, well, if I look there, 1/2 is not big enough. So 1/2 and 3/4 aren't equivalent. So if I shade in my other half, now that's too much. So 1/2 or 2/2 is not equivalent to 3/4. Well, I know 1/8 work well, so let me try 1/8. Let me make my fourths, shade them in, 3/4. And now let me use that to make 1/8. Alright, let me shade in to see if I can get the same size. Oh, there it is. I just found that 3/4 might not be equivalent to anything with halves, but it is equivalent to 6/8. So they are equivalent. So keep that in mind. If you're looking for something equivalent to halves, try fourths or eighths. If you're trying to find something equivalent to 6, try thirds. I do want to point out a few pointers here. One of them I already told you, and that's where the holes need to be the same size. The other pointer I want to point out is if I'm trying to find something equivalent to fourths, and I draw my other hole over here, it's kind of difficult to compare a fraction over here to a fraction over here because they're side by side. I like to stack mine right on top of each other so that I can get the best visual of if they're actually equal or not. Because I'm looking to see how much of it is shaded in, and it's hard to really line them up this way. So that's one pointer. The other one is if I'm trying to find equivalent fractions and I shade in 1/2, and then let's say I'm doing something with eighths. And I shade in here, and then here, and then here, and then this one. Even though really this is equivalent, it's hard to see because I have my shaded in parts all over the place. So again, from the beginning, I've been recommending to the students to really put them all next to each other, and this is why, because here we're needing them to really be lined up to see, is this really equivalent? So a lot of times if I see a fraction like this, I'm just going to change it so that I made my eighths and I'm going to shade in 4 of them. And then I can better compare it to the one here, which was the 2/4. So now I can see 2/4 and 4/8 are equivalent. So go ahead and use those strategies and those pointers when you're doing your equivalent fractions practice.